Okay, we continue the homework for the section 6.2 is verify that the function is one-to-one and find its inverse and check the answer using the graph and do the graph of the f and f inverse. Entonces es exercise 49, 51, 53, 55, 57, 59, 61, 63, 65, 67 and 69. Okay. 57 is the same, but the first is verify if the one-to-one function or no, x and y. Suppose for example for x equal 1, okay, here the value is 4, 1, 2, 3, 4, here the point is 1, 4, this point, and suppose 4 here, 2, 3, 4, 4 divided by 4 is 1. This is the graph, que es obvio que es reciprocal function. And this is completely odd function, it's symmetric. So this point is 4, 1. And when you change, for example, -1 here, and -4. At the point is 1, 2, 3, 4 is here. This point is -1, -4. And this, when you change 4, -1, -3, -4 is -1. Is -4, -1. We have another point. This is a graph. It's obvious you apply the horizontal line test to verify if it's one-to-one or no. The answer is yes. Pass the test is one-to-one, entonces es invertible. Okay, le procedo the inverse. Y equals 4 over x. Interchange x and y. And solve the new y. You apply whatever, cross multiplication. It's xy equal 1 times 4 is 4. So for y is 4 over x. Unbelievable. They are identical. So the inverse function is 4 over x, is exactly the same, the original. Let's check in. The checking is f composition f prime. It's like a 4 over box, and inside the box you copy 4 over x. 4 over 1 is the numerator part time, flip it, x over 4, cancel out the 4 as x. And the other is not necessary to do because it's exactly the same. They are twins, and the graph is the same. Both are coincident, and this is the line que represent the identity function. It's obvious that this function by itself is symmetric with the line y equals x. Okay, so both graphs, the original and the inverse, both are the same. Okay, 59 again is find the inverse. The first is proof case one-to-one function. To prove that, let's do in the graph. It's obvious that this is the reciprocal function, but we have here a vertical shift 2 units to the right. Entonces 1, 2. Here in 2 we have 1 vertical asymptote. So for example, let me select another point 3 here. In 3 here, 3 minus 2 is 1, 1 over 1 is 1. So we have one reference point here, okay, is the point 3, 1. Likewise 1 here, 1 here, 1 minus 2 is -1, 1 minus -1 is -1. So we have here -1, another point here, okay, the point 1, -1. See, I know that the reciprocal function have one vertical asymptote and one horizontal asymptote, que is exactly on the y-axis. approximately the graph will look like that, asymptotically approached. When you apply a horizontal line test, it's obvious que grows in only one point, therefore it's 1 to 1. It says 1 to 1 is invertible. Okay, let's find the inverse. Y is equal 1 over x minus 2. Interchange x and y. X is equal y minus 2. After that, so for y, cross multiplication. Suppose there's 1 here, you multiply x times y minus 2, and 1 times 1 is 1. Now distributing xy minus 2x equal 1. Xy is equal 1 plus 2x divided by x, both sides. Y is equal 1 plus 2x over x, and this is the inverse function. Let's checking using the composition. Okay. The original is 1 over box minus 2. Inside the box I put 1 plus 2x over x. 1 over LCD is x, 1 plus 2x minus 2x. Cancel out, and we have 1 over x. Flip it, is 1 times x over 1, yes, obviously is x. Good. Identity. Okay, after that, let's do it in different order. Let's do it in the checking for f first, f inverse first, composition f. Okay, entonces f inverse is 1 plus 2 box over box, and inside the box I put the function, the original function is 1 over x minus 2. 1 over x minus 2, 1 over x minus 2. Okay? Now LCD. LCD is x minus 2. We have x minus 2 plus 2. And at the bottom we have 1 over x minus 2. Okay, this part cancels out. So we have in the top x minus 2 plus 2 over 1. This is cancelled, and x over 1 is x. Super. The proof. Okay, this is an inverse function. Inverse function is 1 plus 2x over x. Let's do it approximately, the graph. To do it accurate, we can do that using graphic calculator, but let me try to approach. Okay, what idea I'm using? Well, I'm using the idea I have the graph of the original. Let me redo again the graph of the original. Okay. Let's do first the graph of the identity function. Okay, 0, 0, 1, 1, 2, 2, 3, 3. This is identity function. Identity is y equal x in both directions. Now using one color, let's do it in the graph of the original. The original is 1 over x minus 2. Remember, we have the vertical asymptote and 2, 1, 2 here. And we have two reference points, que es 3, 1, and 1, -1. Was approximately the graph of the original look like that. This is the original. Okay. Now let's do in the graph of its inverse. The expression for its inverse is this: 1 plus 2x over x is 1 plus 2x over x. Okay, there are many ways to do that. However, let's do it in the way that this point, for example, this point is the point 3,1, and the inverse would be 1,3. 1, 1, 2, 3 here. Then this point is the point 1, -1. So it would be -1, 1. -1 here and 1 here. Okay. Entonces, now another way to see it, you separate aquí here is 1 over x plus 2x over 2x is 1 over x plus 2. Entonces it's exactly the same of the reciprocal function, but plus 2. Plus 2 is que you have, for example, the vertical shift, and this line represents the line y equal to, que es the horizontal asymptote. Entonces we have, this is symmetric. Let's see, symmetric. We have this. We have this symmetric. So it's like that. Okay. So this point is the same, and this point is the same, and we have one horizontal asymptote and one vertical asymptote at 0. So approximately look like that. Okay, so one branch of the inverse, and also the other branch approximately look like that. Okay, because remember it's a reciprocal plus 2. Si es plus 2, occur the vertical shift to the over 2 units. Entonces normally the horizontal asymptote, que es located at y equals 0, now is y equal to. Okay. Of course we can use the graphic calculator if you want to see much better, but it's okay. I understand.